Hi students, we are going to see friction. Introduction of friction. If a very gentle force in the horizontal direction is given to an object at rest on the table, it does not move. It is because of the opposing force exerted by the surface on the object. It resists its motion. Okay, this is called the, what is the frictional force? Okay, so what is frictional force? It is a 2-mark question. So the frictional force which always opposes the relative motion between an object and the surface where it is placed. Up to this you mark. If the force applied is increased, the object moves after a certain limit. Okay, this friction is two types. That means three types. The basic type is static friction and kinetic friction. The another one is a rolling friction. Okay, what is relative motion? When force parallel to the surface is applied on the object, the force tries to move the object with respect to the surface. This relative motion is opposed by the surface by exerting a frictional force on the object in a direction opposite to applied force. So frictional force always acts on the object parallel to the surface on which the object is placed. Okay, so friction force is always opposes force for applied force. So therefore two kinds of friction, that is static friction and kinetic friction. Now we are going to see static friction, that is Fs vector, because you see the direction. So Fs vector, its notation, its symbol. Then static friction is the force which opposes the initiation of motion of an object on the surface when the object is at rest on the surface. Now only two forces act on it. They are the downward gravitational force and the upward normal force. Okay, you already know that is two forces acting on the body in every time. Okay, so what is static friction? Mark this one. So the force which opposes the initiation of motion of an object on the surface. Okay, up to this you mark it. So the resultant of these two forces on the object is 0. So the upward force normal and downward force gravitational force is equal. So the body becomes at rest. If some external force is applied on the object parallel to the surface on which the object is at rest, so the surface exactly an equal and opposite force on the object to resist its motion and tries to keep the object at rest. It implies that external force and frictional force are exactly equal and opposite. So therefore no motion parallel to the surface takes place. That means the object does not move. If you increase the force, okay, increase the force, external force is increased, then the object is moved. After some particular limit, the surface cannot provide sufficient opposing frictional force to balance the external force on the object. As a result, the object moves. Okay, that means it slides. This is the maximal static friction that can be exerted by the surface. So experimentally, it is found that the magnitude of static frictional force Fs satisfies the empirical relations. That is, 0 is less than or equal to Fs is less than or equal to mu s ns, where mu s is the coefficient of static friction, and N is the normal force, okay, exerted by the surface on the body. And this static coefficient of static friction depends on the nature of the surface in contact. Then this normal force and normal force is equal to mg. It need not be equal to mg always. Okay. Then the force of static friction can take any value from 0 to mu s n. If the object is at rest and no external force is applied on the object, the static friction acting on the object is 0. That means Fs it becomes also 0. So the object is at rest and there is an external force applied parallel to the surface, then the force of static friction acting on the object is exactly equal to the external force applied on the object, that is Fs equal to F external, but still the static friction Fs is less than mu s n. When object begins to slide, the static friction acting on the object attain maximum. After this maximum value, the object slides. Okay. So the static and kinetic frictions depend on the normal force acting on the object. If the object is pressed hard on the surface, then the normal force acting on the object will increase. As a consequence, it is more difficult to move object. For this diagram, it is the force is applied horizontally. It means parallel to the surface, so it move easier. But some mass m2 kept on m1, so it is move harder to move. Okay, do you understand? I hope you understand this one. And next one is the kinetic friction. If the external force acting on the object is greater than maximum static friction, the object begin to slide. When an object slides, the surface exert a frictional force called kinetic friction. Okay, note this one. Mark this one. When an object slides, the surface exert a frictional force called kinetic friction, or sliding friction, or dynamic friction. To move an object at constant velocity, we must apply a force which is equal in magnitude and opposite to the direction of kinetic friction. Okay. So the external force applied on positive x direction. So kinetic friction opposes the external force direction. So it means negative x direction. Suppose the external force act negative x direction, the frictional force act positive x direction. So the magnitude of kinetic friction satisfies Fk equal to mu kn. So mu k is the coefficient of kinetic friction and n is the normal force exerted by the surface on the object. So mu k is less than mu s. Okay, this implies that starting of a motion is more difficult, okay, than maintaining it. So next one is the salient features of static and kinetic frictions. Static friction. Static friction opposes the starting of motion. Kinetic friction opposes the relative motion of the object with respect to the surface. In the case of static friction, independent of surface of contact, and kinetic friction also independent of surface of contact. Static friction mu s depends on the nature of materials in mutual contact, but in the case of kinetic friction depends on the nature of materials and temperature of the surface. Static friction depends on the magnitude of applied force. Kinetic friction independent of magnitude of applied force. Static friction can take values from 0 to mu s n. It can, in the case of kinetic friction, can never be 0 and always equal to mu k n. Whatever be the speed, that is to less than 10 meters second power minus 1. Okay, and kinetic friction is less than maximal value of static friction. But in the case of static friction, Fs maximum is greater than Fk, and static friction mu s is greater than mu k. But in the case of kinetic friction, coefficient of kinetic friction is less than coefficient of static friction. And then next one is to move an object, push or pull, which one is easier? So when a body is pushed at an arbitrary angle theta, that is 0 to pi by 2. Okay, in the case the applied force F can be resolved into two components, that is F sin theta and F cos theta. This F sin theta is parallel to the surface, but F cos theta is normal to the surface, but it acts downwards, so it perpendicular to the surface. So the total downward force acting on the body is mg plus F cos theta. It implies that the normal force acting on the body increases. So there is no acceleration along vertical direction. So you draw this free body diagram. The block is a point mass and Fs is a negative x direction and normal act upward direction and mg act downward direction. Okay. Normal act downward direction only. So there is F cos theta. Okay. Normal act upward direction, but the component is F cos theta act downward direction. Okay. So you write this one is, that is F push equal to mg plus F cos theta. How do you write this one is, that is, you already know, according to the Newton's second law, F equal to ma, but a becomes 0. Okay, a equal to 0. So F equal to 0. So in this case, normal push act upward, then downward force act mg and F cos theta act downward direction. So that is, this one is F. So these two forces are equal. So according applying this Newton's law, so you get n push minus mg minus F cos theta equal to 0. Okay, do you understand this one? So you push n push equal to mg plus F cos theta. Okay, do you understand this one? As a result, maximal static friction also increases and is equal to Fs maximum equal to mu s n push, that is equal to, apply this n push value, so mu s into mg plus F cos theta. Okay, this is a frictional force. Okay, so greater force needs to be applied to push the object into motion. Okay, then when an object is pulled at an angle theta, the applied force is resolved into two components. Okay, the same, this one. So F cos theta is perpendicular and normal direction, normal force direction. F cos theta act normal force direction, but F sin theta act negative x direction. So Fs act positive x direction. Okay, so you write F equal to ma, a equal to 0, so F equal to 0. So in this case F equal to 0, F equal to 0, F equal to 0. So F equal to n pull plus F cos theta minus mg. So n pull plus F cos theta minus mg equal to 0. So n pull equal to mg minus F cos theta. Okay, but F push equal to mg plus F cos theta. So which one is easy? N pull is only easy. Okay, so the normal force is less than n push, and it is easier to pull an object than to push to make it move.